The food production challenge during World War II was staggering in scale. Britain imported approximately 70% of its food before the war, and German U-boats threatened to starve the nation by sinking supply ships. The United States needed to feed not just its own population, but supply Allied nations through Lend-Lease programs. Germany faced Allied blockades that limited imports. Every major power confronted the same problem from different angles: produce more food domestically using fewer resources with a depleted workforce. Synthetic nitrogen fertilizer, which modern agriculture depends on heavily, was largely unavailable for civilian use. The same industrial process that creates fertilizer also creates explosives, and military demand took priority. Pesticides faced similar constraints. Farm machinery sat idle when fuel was rationed. The workers who knew how to maximize production were fighting overseas instead of tending fields. Under these constraints, agricultural ministries and extension services across the Allied nations turned to intensive guidance programs that emphasized one core principle above all others: rotate your crops intelligently, and the land itself will provide what synthetic inputs cannot. Let's examine all 8 techniques. Technique 1. The modernized Norfolk four-course rotation. The foundation of scientific crop rotation traces back to 18th century Norfolk, England, where farmers developed a system that revolutionized agricultural productivity. The classic sequence moved through wheat, then turnips, then barley, then clover, and back to wheat again. Each crop served a specific purpose that prepared conditions for the next. Wartime agricultural planners modified this proven system for the desperate circumstances they faced. The root crop phase, traditionally turnips grown for animal feed, shifted toward potatoes for direct human consumption. The clover phase sometimes incorporated other legumes. Timing adjustments accommodated reduced labor availability, but the core principle remained unchanged. The rotation works because each crop addresses a need created by the previous crop while preparing conditions for the next. Cereals, like wheat and barley, extract nitrogen heavily from the soil. The clover phase that follows fixes atmospheric nitrogen through bacteria in its root nodules. Restoring what the cereals depleted, root crops require deep cultivation that breaks up compacted soil layers. The cereals that follow benefit from this improved soil structure. No land sits fallow in this system. Every year, every field produces something useful while contributing to long-term fertility. Wartime Britain couldn't afford fallow years, and the Norfolk rotation eliminated them entirely. Legume integration for nitrogen fixing. When synthetic nitrogen became unavailable for civilian agriculture, farmers returned to the original source of soil nitrogen that had sustained farming for thousands of years: leguminous plants. The family that includes clover, alfalfa, peas, beans, and vetch perform a feat of biological chemistry that no other plants can match. Legume roots host bacteria called rhizobium in specialized structures called nodules. These bacteria convert atmospheric nitrogen gas, which plants cannot use directly, into ammonia and related compounds that plants can absorb. The nitrogen fixed in these nodules remains in the soil when the legume crop is harvested or incorporated, becoming available to whatever crop follows. A good stand of clover can fix 50 to 200 pounds of nitrogen per acre, depending on conditions. This approaches or exceeds what farmers might apply as synthetic fertilizer. The difference is that the legume provides this nitrogen for free, using only sunlight and atmospheric nitrogen that exists in unlimited supply. Wartime agricultural programs promoted legume cultivation intensively. Red clover and white clover improved pastures while building nitrogen reserves. Alfalfa provided hay for livestock, while its deep roots fixed nitrogen throughout the soil profile. Field peas and broad beans fed people directly while contributing to soil fertility. Winter vetch covered ground during cold months when nothing else would grow, fixing nitrogen and protecting soil from erosion. Victory garden guides emphasized beans and peas specifically because they contributed to soil improvement while providing nutritious food. Home gardeners learned that following beans with nitrogen-hungry crops, like corn or cabbage, took advantage of the fertility the beans had created. Technique 3. Deep-rooted and shallow-rooted crop alternation. Different crops send their roots to different depths. And this simple fact creates opportunities that wartime farmers exploited systematically. Alternating between deep-rooted and shallow-rooted crops accesses nutrients throughout the entire soil profile. Rather than depleting only one layer, Deep-rooted crops like alfalfa can send roots 20 feet or more into the subsoil. Carrots, parsnips, and other taproot vegetables penetrate several feet. These deep roots access nutrients that have leached below the reach of shallow-rooted plants, effectively mining the subsoil and bringing fertility back to the surface when the plants die or are incorporated. Shallow-rooted crops like lettuce, spinach, onions, and many herbs concentrate their feeding in the top several inches of soil. Following a deep-rooted crop, they find abundant nutrients that the predecessor brought up from below. Meanwhile, the deep root channels left by the previous crop improve drainage and allow air and water to penetrate. The physical effects matter as much as the nutritional effects. Deep roots break up compacted layers that would otherwise restrict water movement and root growth. This biological subsoiling reduces or eliminates the need for mechanical deep tillage. Wartime farmers with limited fuel for tractors appreciated any technique that reduced machinery requirements. Technique 4: heavy feeder, light feeder, and soil builder sequences. Wartime agricultural educators developed a simplified framework that even inexperienced gardeners could apply. They categorized crops by their nutrient demands and designed rotation, sequences that prevented soil exhaustion while maximizing production. Heavy feeders extract significant nutrients from the soil and need abundant fertility to produce well. This category includes corn, tomatoes, cabbage, and other brassicas, squash, and potatoes. These crops should follow soil-building phases when nutrient levels are highest. Light feeders have more modest requirements and can follow heavy feeders without dramatic yield reduction. Root vegetables like carrots, alliums like onions and garlic, and many herbs fall into this category. They thrive on the residual fertility that heavy feeders left behind. Soil builders actively improve fertility rather than extracting it. Legumes fix nitrogen. Cover crops add organic matter. Green manure crops grown specifically for incorporation feed soil biology. These crops should follow light feeders, restoring what previous crops extracted and preparing for the next round of heavy feeding. A typical wartime victory garden rotation might plant tomatoes and cabbage in a bed that had grown clover the previous year. The following year, that bed would grow carrots and onions. The third year, it would return to clover or another legume. The cycle then repeats. Technique 5: pest-breaking rotation by crop family. Chemical pesticides were scarce or unavailable during World War II, which meant that farmers needed alternative approaches to manage insects and diseases. Crop rotation proved to be one of the most effective tools available, exploiting a fundamental weakness in how most agricultural pests operate. Many pest insects and disease organisms are highly specialized. The Colorado potato beetle feeds on plants in the nightshade family and cannot survive on other crops. Clubroot disease affects brassicas but not tomatoes or beans. Corn rootworm larvae die if they hatch in a field that doesn't contain corn. This specialization, which normally helps pests find their preferred hosts, becomes a fatal vulnerability when rotations deny them access to those hosts. Pests that overwinter in soil or crop residue emerge the following spring, expecting to find the same crop they fed on the previous year. When rotation has moved that crop to a different field, the pests find nothing to eat. Population crashes follow. The longer the interval between plantings of the same crop family, the more complete the pest suppression. Wartime extension guidance emphasized grouping crops by botanical family for rotation planning. Nightshades, which include tomatoes, potatoes, peppers, and eggplant, should not follow each other. Brassicas, like cabbage, broccoli, and turnips, share pests and diseases. Cucurbits, including squash, cucumbers, and melons, form another group. Rotating between these families ensures that no pest population builds to damaging levels. The recommended interval varied by specific pest pressure, but 3 to 4 years between crops of the same family was common guidance. Some particularly persistent diseases warranted even longer intervals. Lay farming with integrated livestock. British agricultural scientists championed a system during the war years that integrated crop production with temporary pastures in a way that built soil fertility to remarkable levels. The lay farming system alternated several years of grass and clover pasture with several years of arable crop production using livestock to cycle nutrients and build organic matter. The term lay refers to temporary grassland established within a rotation, as opposed to permanent pasture that never gets plowed. A typical lay rotation might maintain grass and clover for 3 to 4 years, grazed by cattle or sheep, then plow the lay and grow arable crops like wheat, oats, or potatoes for 3 to 4 years before returning to grass. The benefits compound over the grass phase. Grass roots penetrate throughout the topsoil, adding organic matter continuously. Clover, mixed with the grass, fixes nitrogen. Grazing animals consume the forage and deposit manure, cycling nutrients back to the soil in concentrated form. Soil biology flourishes under the permanent plant cover. When the lay is finally plowed, the accumulated fertility drives exceptional yields in the arable crops that follow. The wheat or potatoes grown on newly plowed lay ground consistently outperformed crops grown in continuous arable rotations. Technique 7. Catch cropping and succession planting. Wartime food production demanded that not a single square foot of ground sit idle for a single unnecessary day. Catch cropping and succession planting techniques squeezed additional harvests from the growing season without requiring additional land. Catch cropping means growing a quick-maturing crop between two main crops, capturing productivity from time that would otherwise be wasted. After early peas finish bearing in midsummer, a fast crop of lettuce or radishes can mature before the ground is needed for fall brassicas. After harvesting early potatoes, quick beans can produce before frost. The catch crop captures nutrients that might otherwise leach away while providing additional food. Succession planting means planting the same crop at intervals to ensure continuous harvest rather than a single glut. Instead of planting all your lettuce at once and harvesting it all within 2 weeks, you plant a small amount every 2 weeks throughout the season. This provides steady supply for the kitchen rather than overwhelming abundance followed by nothing. Victory Garden guides emphasized both techniques intensively. Planning charts showed exactly when to plant catch crops for each region. Succession planting schedules specified intervals for different vegetables. The goal was maximum productivity from limited space, and intensive scheduling achieved it. The labor requirement was significant. Green manure cover cropping. When no food crop occupies a piece of ground, that ground is losing fertility. Exposed soil erodes. Nutrients leach away with rain. Soil biology starves without plant roots to sustain it. Wartime farmers learned to keep ground covered with living plants continuously, and when those plants couldn't be food crops, they grew cover crops specifically to maintain and build the soil. Green manure refers to crops grown specifically to be incorporated into the soil rather than harvested. The plant material feeds soil organisms, adds organic matter, and returns nutrients to the root zone where food crops can access them. Leguminous green manures additionally fix nitrogen, adding new fertility from the atmosphere. Winter rye became a workhorse cover crop because it grows actively during cold weather, when nothing else will. Planted after fall harvest, winter rye protects soil through winter and can be incorporated in spring before planting. Its extensive root system adds organic matter throughout the topsoil. Crimson clover provides both nitrogen fixation and beautiful blooms that support pollinators. Field peas combine nitrogen fixation with cold tolerance. Buckwheat grows so rapidly it can serve as a summer cover between spring and fall crops, and its roots access phosphorus that other crops cannot reach. Mustard family covers provide biofumigation effects that suppress soil-borne diseases when incorporated. War agricultural committees in Britain distributed cover crop seeds through agricultural programs, recognizing that maintaining soil fertility was essential to sustain production. Extension services in America promoted cover cropping in their Victory Garden guidance. The practice was understood as non-negotiable for serious food production. Every one of these techniques emerged, or was refined, because farmers had no choice. The inputs their predecessors had come to depend on were building bombs instead of fertility. What they discovered under those constraints was that intelligent rotation produced more food, more sustainably, than any amount of synthetic amendment. Modern agriculture spent decades ignoring these lessons, substituting purchased inputs for biological processes that cost nothing. The bill for that substitution is coming due in depleted soils, resistant pests, and rising input costs. The solutions remain exactly where wartime farmers found them: in rotations that balance crop demands with soil capacity, in legumes that pull fertility from thin air, in diversity that breaks pest cycles and builds resilience, in management that treats soil as a living system rather than a passive medium. The techniques that sustained nations during total war still grow more food per acre than anything developed since. Thanks for watching.